Hi, my name is Richard Wu. I'm a junior at Aime Valley High School, and today I'll be presenting 2018 Aime Ii number 12. What this question says is that in a quadrilateral ABCD, we have AB equals 10, BC equals 14, CD equals 10, and AD equals 2 root 65. And we also have ABP, the area of ABP, plus the area of CPD equals the area of BPC plus the area of APD. And we also want to find the area of quadrilateral ABCD. First of all, let's set everything with variables as side lengths. So let's let AP be A, BP be B, CP be C, and DP be D. And let's let the angle between them be theta. So how we're going to solve this is that we're going to use a formula that the area of a quadrilateral is 1/2 times the product of the diagonals times the sine of the angle in between them. Sort of like the area of a triangle is 1/2 AB sine theta. In fact, we're going to use that to simplify this equation down only in terms of A, B, C, and D. So the area of triangle APB is 1/2 AB sine theta, CPD is 1/2 CD sine theta, and since the angle BPC is 180 minus theta, and sine of that is sine theta, we have BPC is 1/2 BC sine theta, and APD is 1/2 AD sine theta. So we can simplify the sine thetas. We can do the same thing with 1/2. So now what we get is AB plus CD equals BC plus AD. Now this looks kind of familiar, like we can factor this. So let's move BC and AD to the other side. So to save you some work, I'll show you that this factors as A minus C times B minus D. And we can see that it's the same expression because by foiling it together, we have AB minus BC plus CD minus AD. So that means we have either one or both A equals C and B equals D. But since it isn't a trapezoid, A cannot be equal to C. So, it doesn't have to be A cannot be equal to C, but in our case, A is not equal to C. So in our case, let's just let B equals D. So we can replace D in this equation with B. And basically that's all we know from this equation right here, so let's move on. So we're given that AB equals CD because they're both 10. Now we can use the law of cosines on both of them. A squared plus B squared minus 2AB cosine theta equals B squared plus C squared minus 2BC cosine theta. Now we can cancel out the B squared. We can move the C squared to this side and the negative 2AB cosine theta to this side. So we have A squared minus C squared equals 2AB cosine theta minus 2BC cosine theta. So now look at this. This is a difference of squares, and we can also factor this as 2B cosine theta times A minus C. Well, since A isn't equal to C, we can just cancel this out because it's not 0. So we basically get A plus C equals 2B cosine theta. Okay, so we have one equation, A plus C equals 2B cosine theta. Now let's use the law of cosines with APB and APD. So basically, right now we have A squared plus B squared minus 2AB cosine theta equals 100. And for APD, we have A squared plus B squared. Now this is plus 2AB cosine theta, because the cosine of this angle is negative the cosine of this angle. And that would be 260. Now, when we subtract this first equation from the second, we get 4AB cosine theta equals 160. So we have AB cosine theta equals 40. Now, working on BPC and CPD, we have C squared plus B squared minus 2AB cosine theta equals 100. And by the same reasoning, C squared plus B squared plus 2 CB cosine theta is 196. So just subtract and we get, subtract and simplify and we get CB cosine theta equals 24. I'll write that more neatly. So now we can add these two together, and basically we will get a plus c times b cosine theta equals 64. Remember, a plus c is 2b cosine theta. So let's just erase this, because everyone understands that, I hope. So we have 2b squared cosine theta squared equals 64. And with some simplifying, we find b cosine theta is 4 root 2. So since a plus c is 2 times 4 root 2, a plus c is 8 root 2. Now let's return to our law of cosine formulas, looking at APB and APD again. So we will have a squared plus b squared. Let's just draw a line here separating this. A squared plus b squared plus 2ab cosine theta is 260. So now look what happens when we add them together. We will get 2a squared plus 2b squared, and these cancel out. So we have this as 360. So we have a squared plus b squared equals 180. Now let's do the same thing with c. I'll save you the math, and I'll tell you that c squared plus b squared is 148. So now what we do is we just subtract this. We have a squared minus c squared is 32. And this is to find a minus c, so we can find a and c. And using that, we can substitute a and c back into these equations and find b. And then, since we know b, and we know b cosine theta is 4 root 2, we can find cosine theta, and using that, we can find sine theta, and then we can basically solve the problem after that. So you might notice this is a difference of squares, and a plus c is 8 root 2, so a minus c is 2 root 2. So we have a plus c is 8 root 2 and a minus c is 2 root 2. Well, that means a is 5 root 2 and c is 3 root 2. Well, I hope everyone understands that. So we have this now. Now, let's substitute a in to find b. So from this equation right here, we have b squared equals 180 minus a squared. A squared is 5 squared times 2, which is 50. So b squared is 180 minus 50. This whiteboard's a little bit shaky, so I have to hold it. So that means we have b equals root 130. So now that we have b equals root 130, we don't need all these equations anymore. Because look what we can find. We can find cosine theta, because cosine theta is just 4 root 2 over b. So that means cosine theta is square root 32 over 130. And since sine theta is the square root of 1 minus cosine squared theta, we will have sine theta equals 1 minus 32 over 130. Again, I'll save you the math, and we will get root 98 over root 130. So now we have sine theta is root 98 over root 130. The area of a quadrilateral ABCD is 1/2 times one diagonal, a plus c, times the other diagonal, 2b, times sine theta. But now we know all of these. So we have area equals 1/2. A plus c is 5 root 2 plus 3 root 2, which is 8 root 2. 2b, well, b is root 130, so that's just 2 root 130. And sine theta is root 98 over root 130. Now we can do some canceling out. 130 with 130, 2 with 2. And basically what we have now is area is 8 root 2 times root 98. So since 98 is 2 times 49, we can basically simplify that as 7 root 2. So let's erase this. Area is 8 root 2 times 7 root 2. So root 2 times root 2 is 2, so the area is 112. And is 112 the area we want to find? Yes, it is. So we're done.